All right, guys, starting our brand new chapter here about quadrilaterals. We're leaving triangle land behind and we're going to join the world of many-sided polygons. So if we flip this over in our table of contents, the first topic that we're going to talk about is what a polygon is and how we look at the angles and sides inside and outside a polygon. So we're going to talk about a couple Polygon Sum Theorems, which just as a reminder, like a theorem is really just a math rule that gives us like an equation to use. So we're going to be doing this on page 83, 84, and 85. Although I will say, page 83 right here, I'm not going to fill out with you. This is more for you to kind of fill out while we're working through a Desmos activity in class. Or if you don't fill it out, that's fine too, because we can always just use an equation to solve for these things, which I'll remind you of before the end of this video. So if we turn the page here, starting on page 85, actually, we have our first polygon angle sum theorem, which, again, if you guys did follow along with the Desmos activity that we did in class, we talked about what the polygon angle sum theorem is. I just had a moment where I was like, I want to do something else, actually. So before we talk about that, let's talk about what the heck a polygon is. So the word polygon in its parts, like poly, the term poly means many. And then gon is like a sided, like a many-sided thing. So a sided figure. So literally the word itself means many-sided figure. So we can start being more specific with our polygons once we know how many sides there are. So a polygon has to be closed, which means like all the sides interlock together and there's no like overhang or like open spaces where you can get into the polygon. And it needs to be convex, which the word convex means like everything is popped out. There's no like cave in. There's the other word concave, which maybe you remember, which means like if I was looking at this polygon, concave is where I'd have like a little innie or something like that. So we're dealing with closed and convex polygons. Sometimes we call polygons by different things, which we'll talk about in just a second. But let's get our sum theorems. So the first sum theorem that we talked about is if I want to know all of the angles together, so sum is like all of them added up together, and the sum, or add all up, of the measures of the inside angles of a n-gon, which that just means number of sides, like n stands for number of sides, is always n minus 2 times 180, or if you want to write it 180 times n minus 2. Either way is fine. We're going to do some examples of this, but basically, like if I'm looking at this picture here, I would count up there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So I would do 180 times 10 minus 2. So 180 times 8 to find the sum of all of the inside angle measures, and that's real big. I can do it. 0, 8 is 64, carry the 6. So 1,440 degrees is all of the angle measures in there added up. Another polygon angled sum theorem that we talked about is once I know the sum of all of them, add another definition up here. If I have a regular polygon, okay, so, oh, geez, forgot my G. A polygon is a closed and convex figure. If it's regular, the word regular means that all sides and all angles are congruent or equal. Okay, so looking at this picture here, this is a regular polygon because all the sides are the same and all of the angles are the same. And if that happens, if I know the sum of all of them, then I can find one of them because I can just divide it equally amongst each one. So if I want to find the measure of, oh my word, of each inside angle of a regular n-gon, then I ran out of room here, I guess. The equation for that is our sum, so the 180 times n minus 2, divided by n, because that's how many sides or how many angles there are. And so this means if I want to find just one, I have to do this little extra step of division. And then lastly, if my polygon is regular and all the sides are the same, all the angles are the same, then all of the outside angles are also the same. So we can talk about these exterior angles. Like if I extend my sides, which kind of makes it not a polygon anymore, but we get all these little exterior angles out here. If I like shoot out a little tail, they would all be equal as well. And if you kind of notice the shape here, it's doing like a circle thing. So the sum of the measures of the exterior angles or outside angles of a polygon is always 360. However, again, if I'm regular and we want just one outside angle, we can do 360 divided by n because there's n sides and I just need to divide that 360 equally among all of them. Ugh. So, sorry, tripping on my words. Let's try that now. So if we jump over to page 84, I have a whole bunch of examples for you using different things. And we also want to talk about these special polygon names that I mentioned before. Like if I have 3 sides, I don't just call it a polygon. That's a triangle. If I have 4 sides, I don't just call it a 4-sided polygon or a fourgon. I would call it a quadrilateral. And other polygons have special names as well. Like, I don't know if you know, but a 5-sided figure, a 5-gon, is a pentagon. Scary. A 6-sided gon uses the little prefix that 6 is, maybe you know it, hexagon. 7 is real interesting because 7 is not like a number that we talk about prefixes very often, but 7 does, a 7-gon, a 7-sided figure, does have a special name. I love it. It's so cute. It's heptagon. It's just so weird. Like you'd think it'd be something, I don't know. Like hexa makes sense to me, like I guess because of the X and the 6, but hepta is so weird. I don't know, but I love it. It's cute. An 8-sided gon or an 8-sided figure is an octagon. That one makes so much sense. Like we know oct is 8 because octopus. And it's a stop sign. An n-gon is super cute. It has a name. It's a nonagon. And there's a really fun song by There Might Be Giants called Nonagon. It's so good. Maybe I'll post it. It's so funny. 10 has a name. It's a decagon. 11 also has a name, and I always forget it. And I kind of don't care. Like usually 11, I'm not calling it by its name. I'm just calling it an 11-gon. If you look it up and you know it and you want to add it to the comments here, I would love that because I really don't know it off the top of my head right now. But 12 I know. It's a dodecagon. And again, I forgot to mention like deca is like decade, so like 10. And dodeca is like do is 2, so 2 and 10 for 12. So that's cute. All right, trying some of these out in here. If I wanted to find the sum of the interior angles, then I can use our Polygon Sum Theorem, which if I want to find the sum, it's just 180 times n minus 2. So 180 times n minus 2, where n is the number of sides. So for this one here, I would do 180 parenthesis 3 minus 2, which is 180 times 1, which is just 180 degrees, which we already knew that that was the case for a triangle, but it's good to see that it still works out for ones that I just know. Because for ones that I maybe don't just know off the top of my head, I want it to make sense as well. So 180, here I have 1, 2, 3, 4 sides, so 4 minus 2. And 4 minus 2 is 2, and 2 times 180 is 360 degrees. And maybe that's another one for a quadrilateral that you just knew. Now the last one that I have here is a pentagon, so 1, 2, 3, 4, 5 sides. So I do 180 times 5 minus 2, which is 3, and then 3 times 180 is 540. Now that's not one that I just know off the top of my head. Like I always kind of got to do the math for that. Although I guess that's a little bit of a lie. Like I used to play this video game called like 1080 snowboarding. It's like a really old video game, but they would always talk about like when you're snowboarding, you can do a 180 or a 360 or a 540. And so I kind of know them because they're all multiples of 180, but not always off the top of my head. So it's good that we have a formula. And the minus 2 thing comes from like 2 of the sides. Like you always have to, when you're drawing your diagonals, you always have to take off 2 of the sides kind of. Anyways, we did it in the Desmos. Hopefully you remember. Find the value of x. Well, if I look at this little picture right here, all of the x's are on the angles. And so if I add all of these up, I will have the sum of all the angles. I can also find the sum of all these angles by doing 180 times n minus 2. So I write down each of these little baby equations and add them all up. So 3x minus 5 plus x plus 10 plus 4x plus 8 plus 12x, oh my word, plus 6x plus 7. And guys, once I add those all up, that is the sum. And so I want to set that equal to the sum of this shape, which I can find by doing 180 times 1, 2, 3, 4, 5 minus 2, because that's also how I find the sum. And I kind of need that so that I can set this equal to something. So now I can go through and combine all these like terms because there's a lot. So like the 6x, 3x, x, 4x, and 12x is 26x. And then the 7 minus 5, so 2, plus 10 is 12, plus 8 is 20, so 20, equals my 180 times 5 minus 2, which is 3, which I just did up here, so 540. And then I can solve for x by just getting it alone, so subtract the 20. So 26x equals 520. And then divide by 26, which normally I would be like, oh, I'm going to use a calculator for that. But I know that 52 is the number of cards in a deck of cards, and 26 is half of that. So this is going to be 2, 0. This 26 goes into 52 2 times. So x is 20. And then I could plug that back in and find all of these angles individually, because the thing is I don't know if it's regular. So I can't really like divide the 540 by 5 and say like each one of these is equal to that, because I don't know if it's regular. I don't know if they're all the same. So this is the better way to do that problem. All right, trying another. If we open this one up, if I want to find the measure, or no, I'm sorry, the measure of an interior angle is 150. Okay, so, and we want to figure out what is the polygon. So if I'm talking about just one angle, then we had 180 times n minus 2 over n to figure that out. And so if we write that out, we got 180 times n minus 2 over n. And the thing is, they kind of already did it for me. They did all that, and they said that it equals 150. which that's important to set up because I want to figure out how many sides there are so that I can figure out what type of polygon it is. And because n stands for the number of sides, I can do this. So I kind of don't like that I have n in the denominator, so I'm going to get that out first. So we'll times by n on both sides to cancel it out of the denominator, and we'll have 180 parenthesis n minus 2 equals 150n. Now, this n is sort of buried over here inside the parentheses, so I am going to distribute. So 180n minus 360 equals 150n. So that I can get my variables on both sides, I would subtract the 180n, and we'll have negative 360 equals negative 30n, and divide the negative 30 on both sides to get that n is 12. So there are 12 sides, so it is a dodecagon. Dodeca. If I can name it, I like to name it. I just think it's cute. Alrighty, so if we try this one here, the measure of an interior angle is 135. Same type of question, so we're going to set it up the same way. So 180 parenthesis n minus 2 over n, because that's how I will find one angle, and it was equal to 135. And so we'll solve the same way. We'll times by n. So 180, and maybe I'll distribute at the same time because that's what we did next. So 180n minus 360 equals that 135n. Subtract that 180n to get my n's together. So we got negative 360 equals negative 45n. And then divide by negative 45 on both sides to get n totally alone. And I know my answer will definitely be positive, but I'm like not sure about this 360 divided by 45. I feel like oh my word, my zero is not working. I feel like I know it, but I'm not sure. Oh yeah, 8. So since the number of sides is 8, this is an octagon. These two are the same. So, I mean, I guess I can do one more. Let's do one more. I just don't want to make this video super long. So the measure of an interior angle is 144. Because we were talking about one interior angle, we're going to use that formula 180 parenthesis n minus 2 over n. And when they did that, it equaled 144. I feel like I can kind of guess because this was like 150 and it was 12. And this was 135 and it was 8. So I feel like it's got to be in between those because the 144 is in between those. But how much? I'm not quite sure. So I'll times that n over, and I'll distribute this. So 180n minus 360 equals 144n. Get my n's on the same side by subtracting. I'm going to totally get interrupted by a bell here in a second, y'all. Sorry. So negative 360 equals negative 36. Divide that negative 36 both sides, and we get 10. So this is a decagon. Alrighty, I'm going to leave that last one because I feel like it's the same thing every time. Last page. So we also talked about the exterior angles, and the sum of the exterior angle measures of any convex polygon, one angle at each vertex, is always 360. So it's just, if we add these little extenders here, this outside angle, this outside angle, this outside angle, outside angle, outside angle, outside angle. So like at each angle, I draw a little extender. If we want the sum, it's 360. But if I want just one, I'm going to do 360 divided by n. So in this case, because this is 1, 2, 3, 4, 5, 6 sides, I would do 360 divided by 6. And so each of those angles are 60 degrees, as long as it's regular, to be fair. Okay? Because there is another way to do it, even if you're not regular. So one way is to do that divide 360 by the number of exterior angles like I just did. So in this picture here, there are 5 sides. So we do 360 divided by 5, which is 72 degrees. But kind of another way to do it that is super interesting is we can find the inside angle, and then it's a linear pair. So like this guy here and that guy there are a linear pair. So since this is a pentagon, I can find one inside angle by doing that 180, parenthesis n minus 2 over n, where in this case n is 5 because there are 5 sides. Sorry. And so 5 minus 2 is 3. And then if we simplify that 180 times 3 is 540 divided by 5 is going to be 18. 180. 180. No, 108. Oh my God. Sorry. 108. So one inside angle is 108 degrees. And so if I do that plus the star equals 180 because they are a linear pair, I subtract that 108 to find that this outside angle is 72. That feels like not the way to do it though. I feel like the better thing to think about is if I find one outside one, I can subtract that from 180 to get one inside one. That's a whole lot of work to find one inside one when I can just find the outside and then subtract from 180 because they're a linear pair. So last thing I'll say, guys, in this video is like, again, this stuff all here, we have our interior angle sum, which is like 180 times n minus 2. One angle is where I do that same thing divided by n, and then an outside one is 360 divided by n. These are just all of our special polygons. So, I mean, you can just do them if you want them listed. Otherwise, like, no need. And that's all for now.